Lastly, in PHPUnit， 那这是PHPUnit 之父 Sebastian 今天要来跟我们分享 PHP 的7.1 7版跟7.1，还有 PHPUnit 5跟6。那Ladies and gentlemen, let's welcome our speaker. The creator of PHPUnit, Sebastian Bergmann.
Hello. Good morning. I'm Sebastian. And this is where I come from Germany, which is really far away. And now I'm here. That's good. I made it. Got in last night. Didn't really have a chance yet to see much of your wonderful country. So far, I've seen the airport, I've seen the hotel, and I've seen the venue. I hope that I get to see a little bit more over the next couple of days. Thanks for having me. I'm 38 years old. I started coding 26 years ago. This was my first computer. I did assembly, C, AREX, and some other languages on there. I started with some BASIC, and then quickly came into assembly using the custom chips of the Amiga. And I'm relearning assembly on the Amiga at the moment. My Amiga still works, not the Amiga 500 that you just saw, but an Amiga 1200. And that's really cool. In 1998, I came across PHP. Back then it was PHP 3.0.14, 15, something like that. And within a weekend, I learned enough PHP to get my first job done using PHP. This was just a really small project for a customer. And eventually, I got interested in testing in general, quality assurance in general, and unit testing in particular. And because there was no tool like that I could find that was able to work with, I created PHPUnit about 15 years ago. At some point, I ran into these two gentlemen, Stefan and Arne. I founded a company with them, the PHP consulting company. We have customers, which is good for a company to have, I guess. So these are a couple of our customers, but I don't want to bore you with that. We recently published a book on PHP 7, which covers all the changes from PHP 7.0 and PHP 7.1. You can find about the book on php7explained.com, and there's a 25% discount that is valid today and tomorrow. Just use PHPConf 2016 during checkout, and you'll get the book for 25% off. So what my goal for this presentation is to have a look back at some of the more recent versions of PHP and PHPUnit, and talk a little bit about what changed and what changes are coming in future versions. So let's do this in a chronological order and start with the past. I'm not really going into ancient times. Then I don't have enough time for that. We could do that. I could talk about PHPFI and PHP 3 and how I started PHPUnit, but we don't have time to go that much back in time. So our timeline starts about 4 years ago. PHPUnit 3.7 came out, and that was the first version of PHPUnit that you could use from a PHP archive from afar, single file that you can download and can immediately use. It was also the first version of PHPUnit that you could install via Composer. Around that time, Composer was fairly new. Not a lot of people were using it. There was much interest in that, but still, most people used the pair installer to download and install PHPUnit. Probably the biggest change in PHPUnit's history was in March 2014 when PHPUnit 4 came out. Biggest change with PHPUnit 4 was the new development process. Before, it took sometimes a year, sometimes 2 years, 2.5 years for a new version with new features of PHPUnit to come out. Since PHPUnit 4, this frustrating release process, which was not really a process, is over. And with the new release process, there's a new version of PHPUnit that brings new features every 8 weeks. Every 2 months, on the first Friday of that month, there is a new version of PHPUnit that is backwards compatible with the previous one and has new features. New features are awesome. So this is a lot less frustrating than what we had before. New features get into the hands of users and are useful much quicker. PHPUnit 4 was also the first release of PHPUnit that was not offered as a pair package anymore. Sorry about that. PHPUnit uses semantic versioning, meaning that you can see from the version number of a new release whether or not it will be compatible with what you're currently using. If, for instance, PHPUnit 5.6 comes out, you know that if you're currently using 5.5, for instance, that you can upgrade to that new version without any problems, and you get new features and improvements. It also means that when PHPUnit 5.6 comes out, PHPUnit 5.5 is no longer maintained anymore. No more bug fixes for that version because there's a newer version that is compatible, so you have to use that if there's a problem. At some point, there will be PHPUnit 6, and I'll talk about that towards the end of the presentation. And when PHPUnit 6 comes out, for a year, there will be bug fix releases and support for the PHPUnit 5 version that is current at the time. PHPUnit 4.8, which is the current version of the PHPUnit 4 line, is supported on PHP 5.3, 5.4, 5.5, and 5.6, which means it's not supported on PHP 7. So if you're using PHP 7, and I hope you are, then you cannot use PHPUnit 4, you have to use PHPUnit 5. PHP 5.6 came out in August of 2014. PHP 5.6 is the current, or it's the last version of PHP 5 and is currently maintained. PHPUnit 5 came out in October of last year. There was no really major new feature, new thing in PHPUnit 5 that warrants the bump in the major version number going from 4 to 5. The reason why I bumped the major version number is because I dropped support for outdated versions of PHP. PHP 5.3, 5.4, 5.5 are no longer maintained by the PHP project, so I dropped support for them. PHPUnit 5, the current stable release line of PHPUnit, is supported on PHP 5.6, PHP 7.0, and the soon-to-be released PHP 7.1. It's not supported on 5.3, 5.4, 5.5. If you are using ancient versions of PHPUnit, you need to use an ancient version of PHPUnit. So last year, almost a year ago, PHP 7.0 was released. It probably was already December 4th here when it came out. There was like a last-minute delay, when the release was delayed by some 12 hours. It was still December 3rd in some parts of the United States when it came out. So somehow we made the deadline that we impose on ourselves. There are 4 major changes in PHP 7. Refactoring of the language runtime. Nowadays, there are multiple implementations of the PHP language that you can choose from. PHP 7, the language runtime that you can download from php.net, has 21 years of history, and the C code of the compiler and the executor needed to be cleaned up to be ready for the future so that we can continuously add new features to it. So that's one major change that was done in PHP 7. There was a lot of language cleanup, stuff that we had deprecated in PHP 4 and forgot to remove in PHP 5 14 years ago or 12 years ago. Stuff that should have been deprecated in PHP 5, but we forgot to deprecate that, and it's now deprecated in PHP 7. Lots of language cleanup. To most people, the most striking change in PHP 7 will be the performance improvements. And feature-wise, syntax-wise, the new type system is of note. So over the years, I've seen a lot of presentations at conferences that talk about major new features of a major version of PHP itself or a tool. And most of these presentations are like 99% of the time, these are all the awesome new things. And then the last minute or so, the speaker will say, yeah, but to get these nice things, some changes had to be made that you probably will not like, and I don't talk about that because that's boring and frustrating and whatever. That kind of presentation style I find frustrating because I would like to explain why certain changes were made. So that's what I try to do. So let's start with the changes under the hood. The executor, the part of the PHP language runtime that executes bytecode, is now a lot faster than it was, and it uses less memory. So just to give you an idea, this is from a PHPUnit test suite. With PHP 5.6, that test suite requires 304 million CPU instructions. Executing the same PHP code with PHP 7 only requires 216 million CPU instructions. So that's about 30% less. That's achieved by a lot of smart changes under the hood in the executor, but also by leveraging optimization techniques from current generation C compilers and CPUs. So that's cool. To give you an idea what this looks like, this is a benchmark with PHPUnit using a test suite that has 450,000 tests. No I/O, real unit tests, no file system access, no network, no nothing. On the left, you see that with PHP 5.6, this takes 147 seconds to run. With PHP 7, only 49 seconds. PHP 5.6 requires 10.5 megabytes of memory to do this. PHP 7, only 8. So while it is up to 3 times faster in most situations, it requires about 25 to 30% less memory. Of course, lies, dem lies, and benchmarks. Your mileage may vary. These are the things that I benchmarked with. This is how I invoke PHPUnit. This is how I build my PHP. So make your own benchmarks. But from what I've seen, both from other benchmarks that Rasmus did, for instance, or what I see in the real world with the projects of our customers, you usually have somewhere between 2 and 3 times the performance with PHP 7 than you had with PHP 5.6, which is quite cool. Talking about the real world, there are a couple of companies that are very open about their migration effort from PHP 5 to PHP 7. This is from a Germany-based company Trivago. And you can see when they made the switch from PHP 5 to PHP 7, their CPU load dropped, their memory usage dropped, and they answer requests much quicker than before. This is from Baidu. They have an interesting blog post where they explain how they save $1 million per year by moving from PHP 5 to PHP 7 because they need a lot less machines in the data center. PHP 7 is faster not only because we can execute bytecode faster, but also because we generate more efficient bytecode. If you take a look at this really, really simple PHP codes fragment, just a simple for loop, with PHP 5.6 we have 10 opcodes, with PHP 7 only 7. And if you've never seen what PHP bytecode looks like, this is what it looks like. If you've ever seen assembly, very similar to that. If you've ever seen Java bytecode for the Java virtual machine, same principles apply. Every function or method is compiled into a so-called op array. Every op array consists of multiple op lines. Each op line has one opcode. PHP has a vocabulary of about 200 opcodes. These opcodes operate on operands. These opcodes have results, but I leave it at that. You don't really need to know about that, unless you're really interested in that, and then you can read up on that. Before the compiler, before the bytecode generation, there's a parser, and here's one of those things that I mentioned earlier with regards to refactoring of the PHP language runtime. The parser used to work, but it was really hard to understand for a developer that was new to PHP project, because the parser didn't work like parsers should work, or like how parsers are taught at university, for instance. So people would come to the project and would say, hey, where can I find the code in the PHP language runtime where the abstract syntax tree is created and manipulated and whatnot? And we didn't have an abstract syntax tree. Now with PHP 7, we finally do. And this is awesome, because now it's really easy and a lot simpler to onboard new developers that want to contribute to the PHP project. And since that was added, a couple of new syntax features that we'll talk about later have been implemented with a lot more ease and by people that hadn't contributed to PHP before. So this is really awesome. So this is probably not something that most users of the PHP language think they should care about. And to some degree they're right, because they don't really need to care about how PHP is implemented, they just want to use it. But in the long run, I think they should care about this, because this enables future contributions. It brings fresh blood to the PHP project, and that's really good. What's more, you can access that abstract syntax tree from PHP itself. So you can write completely new tools that you wouldn't be able to build before. This is what the array structure looks like of the same piece of code using the abstract syntax tree. You can use that to implement static code analysis tools. You can use that to implement refactoring tools. Because if you look at this tree structure, you can rearrange it and then serialize it back to PHP code. So you can do source code transformations on that. Really nice. Even before the parser, there's another step in the compiler called the lexer. And that lexer is now context sensitive with support for semi-reserved words, which means that all these words, which used to be completely reserved in PHP 5, can now be used as names for attributes, constants, and methods in classes, interfaces, and traits, which means you can finally write code like that and it will work. Whether or not you like your code to look like that, that's something completely different, but it would work now, and it didn't work before. Going from PHP 5.6 to PHP 7 is really painless compared to how painful it was to go from PHP 4 to PHP 5. But still, there are some backwards compatibility breaks. Some things had to be broken to make things like the abstract syntax tree work. Because PHP has evolved a lot over its 21 years, and there's a lot of, or there was a lot of really weird syntax in there that was never intended to work, that was never documented. yet people used it, and it was really ambiguous. And with the abstract syntax tree in place, we cannot have ambiguity in the syntax, so some things had to be cleaned up. So the most common problem that people have, if they have a problem at all going from PHP 5 to PHP 7, has to deal with the uniform variable syntax. There is syntax that you can see on the left. Please don't ask me why anyone would write code like that. Some people came up with that. It was never intended to work. It was never documented. It was not really specified what should happen. And in this column in the middle, you see what happened in PHP 5, and in the column on the right, you see what happens now in PHP 7. So it's more consistent in PHP 7. But just because it's more consistent, please don't write code like that. If I look at code like that, I don't understand it, and there's a 10-second rule. If you look at a piece of code for 10 seconds and you still don't understand it, delete it. So, yeah, do yourself a favor, don't write confusing code. It's really easy to find all these places in your code base where you may have code like that. There's a tool called PHP7cc, the PHP 7 Compatibility Checker. You can find it on GitHub. You can download it as a FAR and just point it at your code base. It will statically analyze your code base and will point out, hey, you have this problem on that line in that file. And it's really easy to go through, and in most cases, it's really easy to fix. There are a couple of new reserved words. Sorry, but you can no longer use string or resource as a class name, for instance. Some features that had been deprecated for a really long time have been removed. I really hope that no one is still using the ereg extension for regular expressions. Ereg is not binary safe. Ereg doesn't know the first thing about Unicode. So if you're relying on ereg to check login credentials, for instance, that's a security issue. You don't want to have that. So you should have migrated from ereg over 10 years ago to preg replace, to PCRE, to preg match and preg replace, for instance. Also, for about 10 years, the MySQL developers kept telling PHP developers, don't use the old-fashioned MySQL extension anymore. Use MySQLi or PDO MySQL. And some other stuff. And we forgot to deprecate PHP 4-style constructors in PHP 5. Finally, in PHP 7, they deprecated. It's the first thing that was voted on for PHP 8. They'll be removed in PHP 8. So if you still have those, fix them now. And I couldn't agree more with what my friend and colleague Stefan said. You can't really expect, after over a decade that has passed since PHP 5 came out, to get 2 or 3 times the performance without having to do a little bit of cleanup in your code base. And it's well worth the effort of making those changes. Of course, there are also new features. Everyone wants new features. And this is my favorite new feature. Well, not really that, but this is my favorite feature. PHP 7 does not have any fatal errors anymore. So that's really, really cool. With PHP 5, when there was a fatal error, for instance, when you tried to use a class that was not declared, then PHP process would just die, in this case, with a stack trace. So if you were using PHPUnit, running your test with PHPUnit, and a test ran into a fatal error, the whole execution of the test suite would stop. and there would not be any log files or useful output, so it was really, really frustrating. When that happens with PHP 7, PHPUnit will just try to run the next test and the next test and the next test, and you'll get meaningful output at the end. So if it would have been up to me, PHP 7.0 would have been ready 2 years ago. The refactorings, performance improvements, and no fatal errors, but nobody listens to me. So we implemented, or we got even more new features in PHP 7. Most notably, as I already mentioned earlier, changes related to the type system of PHP. For a really long time, for over 10 years, every once in a while, people requested support for scalar type declarations, meaning that you can use types like string, integer, float, Boolean in the signatures of functions and methods. And a lot of people agreed, yes, we need this. There was agreement on the syntax, but there was never really an agreement on the semantics of what should happen. So now in PHP 7, we are stuck with a compromise. There are two modes of operation. The default one is coercive scalar type declarations. And what that means is, in this example, the method m says, I want a string, I want an integer, I want a float as my parameters. And when the arguments that you pass to that method do not match the expected types of the parameters, then PHP will automatically cast the type from the type of the argument to the type of the parameter. So we can call it with an int, a string, and an int, and get a string, an int, and a float. This is what, or these are not the rules, this is just the result of those rules, if you will. So if you declare a parameter to be a bool, and if you call it with false, you get a bool false. If you call it with true, you get true. If that wouldn't be the case, then something would be seriously wrong. -1 is true, 0 is true, 0 is false, 1 is true, 1.2 is true, empty string is false, string with a character is true, string with an integer is true, string with a false is true, string with a true is true. Yeah, really weird rules. Magic. I like magic in my movies, TV shows, games, and books, but I hate magic in my code. But that's what we have. The same for int, float, and string. I mentioned earlier that there are two modes of operation. Coercive, which is the default one, and strict. This is an example for what the strict mode looks like. So we have two source code files. The one on the top declares our class C with the method m. Method m says I want a string, I want an int, I want a float. And then we have a second source code file where we use that class. And if the first statement of a source code file is declare strict types equal 1, then all calls from this file will be the type declarations of all functions and methods called from within such a file will be interpreted strictly. That's a bit weird, to say the least, in my opinion, because it puts the burden on the caller. Leads to really weird situations that, for instance, if I'm the creator of a library and I put declare strict types equals 1 at the top of all my source code files, because I'm German, I want things to be strict, I want code in my library to be strict, then that's fine. But when somebody else uses my code and they don't put declare strict types equals 1 at the top of their files, then my code is not executed in the way that I want. And that can lead to weird situations. But that's the compromise we got. What's really handy is the introduction of return type declarations. You can now declare the type of the return value of a function or method. Simply add a double colon followed by the type at the end of the function or method signature. And you get an error when the actual type does not match the declared type. We got a couple of new operators. We got the null coalesce operator, which is a double question mark operator. What this does is simply, it allows you to concatenate a couple of variables using a double question mark operator. And the first variable from the left that is not null will be assigned to the left-hand side. This is the combined comparison operator, or as it's more commonly known as the spaceship operator, because it looks like a spaceship. It looks like the TIE fighter. And you wouldn't believe how long a discussion you can get on a mailing list that discusses the PHP language runtime if that is a TIE interceptor, a TIE bomber, a TIE advanced prototype, whatever. It's the spaceship operator. Doesn't really matter what you call it. It's a really neat and handy piece of syntax that allows you to save some typing, especially when you write comparison callbacks, like in this example. So I need callbacks like that a lot. And every time I need them, I just go to where I implemented them the last time and just copy paste. Now I don't have to do that anymore because that rather long line at the top can be expressed with the spaceship operator in a lot less code, which is cool. And a whole lot more. These were just the changes in PHP 7 that are related to syntax and performance improvements. There's so many more changes and new features in the various extensions to the PHP runtime. A lot has changed in MySQL, for instance, in the GD extension and so on. And we can't fit that in just 1 hour, so sorry about that. So PHP 7 has been out for almost a year. So we are starting to get statistics about how widespread PHP 7 is currently used in the wild. So this is a statistic from Jordi, from what he sees on packages.org. So if you just look at people that use Composer in their projects, then PHP 7 within a little less than a year, like in 10 months since its release, is almost at is over 20%. So almost a quarter of all the PHP installations that talk to packages.org are on PHP 7. Now, not everyone is using Composer. They probably just, or everyone that starts a new project or has started a new project in the last couple of years is using Composer. But there's still a lot of really old software out there. So this is one extreme. I'm going to show you another extreme next. This is from the most recent W3 Tech survey. They look at all websites out there that they can find, whatever that may mean. And from all websites out there for which they can determine the programming language that the website is implemented in, they see about 84% of them are implemented in PHP. And for the ones where they can determine the PHP version, this is what they see. They see PHP 7 at 1.7%. They see a lot of PHP 5. Majority is PHP 5 with 97.2%. 0.1% PHP 3 and 1% PHP 4. So that is one extreme. This is another. From my personal experience, the teams that I come in contact with in my work as a consultant, most of them that have started a new project in the last 1 or 2 years did so using PHP 7. A lot of them are either in the process of migrating from PHP 5 to PHP 7 or have finished that migration. So the truth is probably somewhere in the middle there, depending on it's a really hard thing to measure, and there's probably not the one true way of measuring it. So, but one thing that I'm really certain of is that a year after the release of PHP 7, we are in a situation that is a lot better than what we had a year after the release of PHP 5. It took a long time, like 4 or 5 years, before you could see PHP 5 actively used in the wild, and the situation has a lot improved since then, which is quite good. So depending on time zone things, PHPUnit 5.1 was either released on the same day or a day after PHP 7. To be honest, I don't really remember what the big thing was in PHP 5.1, but that's the thing with the release rhythm of every 8 weeks. Sometimes you don't have any fancy new feature at all. Most of the time you have like 1 or 2 new features in PHPUnit. And I think PHP 5.1 was one of those releases where it was just internal refactoring and cleanup to make new features that come in 5.2, 5.3, and so on possible. PHPUnit 5.2 is noteworthy because it changed a common best practice, the common best practice for testing exceptions. And for the longest time, I told people at conferences, and the documentation recommended this, to use the expected exception annotation to tell PHPUnit, hey, in this test, I expect that this exception is raised, and when that happens, mark the test as a success. That still works. But there are a couple of problems with that. Most notably are 2 problems. One, an annotation is just a string inside a comment, so it cannot be verified by the IDE. It can be verified by PHP itself. If you have a typo in there, then your test is wrong. That's not good. And it also prevents you from using short names for namespace classes. So if you put that into code, into actual code, like what is the suggested best practice since PHPUnit 5.2, using the expect exception method, then you can use things like the class constant that is defined on all classes and contains the fully qualified name of that class. So in actual code, you have the name of the class encoded, and when that class does not exist, PHP Storm, for instance, will tell you, hey, this class doesn't exist. Are you sure you wrote the name of the class correctly? And PHP can tell you the same when you're trying to run the test. The other thing is, if you put the expected exception into the annotation, that exception will lead to success of that test, no matter where in the life cycle of the test that exception is raised. Maybe you are only interested in that exception at a very specific point in time, and if it's raised before that, then the test should be a failure. And that's something that you cannot express with the annotation. With this method, you tell PHPUnit, I expect this exception between this line of code and the end of the test method. And if it happens before, the test will fail. Not an April Fool's joke. PHPUnit 5.3 was released this April. And it has a lot of new warnings that PHPUnit gives now when you may be doing something wrong with regard to stubbing and mocking. And the reason why these warnings are there is direct feedback from a training course that I was running around the time during the release cycle of that release. And I had people in that course that were using PHPUnit for the very first time, were stubbing and mocking for the very first time. Some of the developers were even using PHP for the very first time. And they ran into all sorts of interesting problems that I had never imagined that people can run into. And PHPUnit would behave in really, really weird ways. For instance, when you're trying to mock a class that doesn't exist, or when you're trying to configure a method on a stub or a mock that cannot be configured because it's private or final, for instance. So now there are a lot more checks in place, and PHPUnit tries to give understandable and helpful error messages so that you can fix your tests. PHPUnit 5.4 introduced a forward compatibility layer because PHPUnit 6, which will come out next year, will finally be using namespaces throughout. So over the last couple of years, I've continuously refactored PHPUnit, taking parts of it, ripping the parts out, and making them separate packages. And all these new packages use namespaces. Now it's time for PHPUnit itself to be namespaced, to shed the last remainder of the pair legacy. So to prepare for that, there's now a forward compatibility layer, just like there will be a backwards compatibility layer in PHPUnit 6. So if you want to use the new class name, you can do that since PHPUnit 5.4. And don't ask me why, but this makes a lot of people very, very happy, because they don't see those ugly underscores anymore and get the nice backslashes. I couldn't care less about that, but people want what people want. Much more important, in my opinion, in PHPUnit 5.4 is the new create mock method. So the get mock method, if you want to put it nicely, it evolved a lot over the course of 10 plus years. Got more and more and more optional arguments, which is not really good API design. And let's be honest about it, there was no real design involved. It just happened, and that's bad. Most people wanted the fifth or sixth optional argument to be true, and the default was false, and led to really ugly code. And that was not nice. So that's why I created createMock, which calls getMock basically with sane best practice defaults. So you disable the original constructor, you disable the original clone, you disable argument cloning, and you disallow the mocking of unknown types. That's what you want in 99% of the cases. If you need something else, you can still use getMock builder, but please do yourself a favor, stop using getMock. Security support for PHP 5.5 ended a couple of months ago, which means at the moment only PHP 5.6 and PHP 7 are supported by the PHP project. PHPUnit 5.5 was released. PHPUnit 5.5 added create partial mock. If you only want to stop or mock a subset of the methods of a class, then you can use create partial mock. Builds upon the idea of create mock. PHPUnit 5.6 came out just a couple of weeks ago, and it introduces create configured mock, which is really helpful in a lot of situations. Gives you a shorthand, convenient syntax for saying, okay, if the method bar is called, then please return the hard-coded value baz. Lot less typing. Developers are lazy. Developers don't want to type a lot. So that's where features like this come from. Okay. So I have a couple of minutes left for the future. So PHP 7.1 will be released soon. Whatever soon may mean. Could be in 2 weeks. We just there was just this week there was another release candidate. If that release candidate is good enough, then it will be released unchanged in about 2 weeks. If there are serious problems, there will be another release candidate. Just like it is in open source projects, it's ready when it's ready. But I do think that at some point during November, we'll get PHP 7.1. And here are the highlights of PHP 7.1. I have no idea how that happened, but it was forgotten to implement the void return type in PHP 7.0 when the return type declarations were implemented. So there was in PHP 7.0 there is no way to declare that a function or method does not have a return value. And this is actually a thing that is enforced at compile time, not at runtime. So if PHP compiler sees code like this, hey, here's a method that says I do not have a return value, and then there's a return statement in there, PHP compiler will say, no, I won't let you run this. It claims that there's no return value, yet it has a return statement. Go fix your code. PHP now has support for nullable types. You can mark or denote that a parameter may be null by prefixing that parameter's type with a question mark. So what this means is question mark int $x. The value of parameter x may be null. When it's not null, it must be of type integer. Before, you could only express something very similar by abusing PHP's syntax for optional arguments. Now it's much clearer. Optional argument is separate from nullable parameter. There's a new iterable supertype, which is really great because now you can write functions or methods and express using a type declaration that you want to iterate over a list of elements, and you don't really care about how that list is implemented. It could be just a PHP array, like in this example. It could be a generator function that is a function that uses the yield statement, or it could be an object that implements the iterator interface, like in this example. So that's really neat. Don't ask me why you would want to do this. I've never missed this feature, but now you can catch multiple exception types. This is a first glimpse into what the union types could look like at some point in the future. But for now, we only have the syntax for catching exceptions. So this statement says, okay, this block handles exceptions of the type foo exception and bar exception. This I have really missed a couple of times over the years, so it's nice that it's finally there. Class constant visibility, you can now declare class constants as public, private, or protected, making it possible to use constants instead of magic numbers, magic values in your code without having to make them public. Keep them as an implementation detail. That is nice. Asynchronous signal handling is now possible when you're using the PCNTL extension to do stuff. So for instance, you can register a callback for the SIG alarm signal, and then turn on asynchronous signals and sleep for 2 seconds in this example. And after 1 second, the alarm triggers and aborts the execution of the code because we are throwing an exception. I don't really know where this type of code would be useful, except inside PHPUnit, where I use this to implement test timeouts. So there's a feature in PHPUnit where you can say all tests have to run within 1 second or 10 seconds or whatever. And when that limit is reached, test is aborted and marked as failed. PHPUnit 5.7 will be released in December. Don't really know yet what will be in there. We'll see. Also this December, active support for PHP 5.6 will end. After December 31st, PHP 5.6 will get no more bug fixes from the PHP project. Yes, Ubuntu and Red Hat and whatever vendor will support PHP 5.6 for longer, and depending how much money you are willing to give to Red Hat, for instance, that can be quite some time. As far as I know, they offer support for up to 20 years, but then it's really expensive. But active support from the open source PHP project will end this year. There will still be security fixes, but no more bug fixes. That means in 64 days, PHP 5 is no longer supported by the PHP project. So now is the time to upgrade. In February, there will be PHPUnit 6. So far, there are no new features for PHPUnit 6, but a lot of changes that are incompatible with PHPUnit 5. So a lot of cleanup, a lot of features that have been deprecated a while ago. A lot of stuff has been removed. Just go to the GitHub website and have a look. Most important thing, PHPUnit 6 is no longer supported on PHP 5. So PHPUnit 6 will be PHP 7 only. Well, I have a slide for that. So on the day that PHPUnit 6 comes out, support for PHPUnit 4.8 will end, which is currently the old stable release of PHPUnit. Active support for PHP 7.0 will end December next year, so no more bug fixes. Support for PHPUnit 5.7 will end February 2nd, 2018. We're now far in the future, so I don't know what new features will be there. I only can tell you when I'm taking things away. But that's how the future looks. So, security support for PHP 7.0 will end December 3rd, 2018, which is a bit odd because that's before security support for PHP 5.6 ends, but that's how it goes. So years support for PHP 5.6 is 2 years after active support ends, which is one year more than normal because it's the last release of PHP 5. I really hope that everyone has upgraded to PHP 7 well before that. But considering that I'm dealing with legacy projects at my customers where they're still using PHP 5.0, PHP 5.1, PHP 5.2, PHP 5.3, I don't expect everyone to be on PHP 7 by the time that security support for PHP 5.6 ends. But I would be more than happy to be proven wrong. Would be awesome. So that's it. That's a look back at what recently happened over the last 2 years or so in PHP 7 and PHPUnit, and an attempt to look into the future. Thank you.